we are given this equation. We're given y to the 5th power plus x squared y cubed is equal to 1 plus x to the 4th times y, and we're asked to find dy dx. Now we need to do this by implicit differentiation. We're asked to find dy dx, that is the derivative of y with respect to x, but here we have that y is actually defined implicitly, right? It's not y equals something with just x's in it. So therefore, we can go ahead and just differentiate every term, but whenever we see something that has a y in it, we're going to have to tack on that dy dx, which is pretty much by the chain rule. So just looking at y to the 5th, well, the derivative of y to the 5th with respect to y is just going to be 5y to the 4th. But again, we have to take now the derivative of y with respect to x. We could think of this as like, instead of just y to the 5th, like blop to the 5th, because it's not just x. So therefore, it's going to be the derivative of blop to the 5th is 5 blop to the 4th. That's 5y to the 4th, but then times the derivative of the blop. Well, that's the derivative of y with respect to x. And the name for that is dy dx. dy dx is the derivative of y with respect to x. Okay, so the derivative of y to the 5th with respect to x is 5y to the 4th, dy dx. And then we have plus, well, we have now a quotient, not a quotient, a product. We have x squared times y cubed. So we have a product. We're multiplying two things here. We have to use the product rule. So the product rule says we take the first, which is x squared, the first times the derivative of the second. Well, the derivative of the second is the derivative of y cubed, which is going to be 3y squared. So the first times the derivative of the second, so 3y squared, but then times the derivative of y with respect to x. We got to tack on here a dy dx. Okay, that's just going to be the first times the derivative of the second, and then plus the second. So plus the second. So plus y cubed, and then times the derivative of the first, which is going to be 2x, right? Because the derivative of x squared with respect to x is just 2x. Okay, so we have the first times the derivative of the second plus the second times the derivative of the first. So that right there, x squared y squared dy dx plus y cubed 2 times 2x is going to be the derivative of x squared y cubed. Okay, and then that's going to be equal to the right side. So we differentiate the right side. Well, the derivative of 1 is just 0. So we have basically equal to 0, and then plus, well, the derivative of x to the 4th y, again, another product. So we take the first again. So the first is x to the 4th times the derivative of the second. Well, the derivative of the second is going to be dy dx. So the first times the derivative of the second, and then plus the second. So plus y times the derivative of the first, which is going to be 4x cubed. All right, now we can go ahead and clean this up a little bit. Let's go all the way back here. Okay, so what do we have? We have a 5 y to the 4th dy dx, and then we have plus, we have x squared 3y squared dy dx. We write that, I guess, as maybe 3 times x squared times a y squared, and then we have a dy dx. Okay, and then we have, plus, so y cubed times 2x, we write that as plus 2 either xy cubed or y cubed x, same thing. And then is going to be equal to the right side. We can't do too much. What we have is equal to x to the 4th dy dx, and then plus y times 4x cubed. You can write it as 4x cubed y. Okay, and then we want to basically solve this for dy dx. We want to go ahead and get all the dy dx terms on one side of the equation. We can then factor it out, and then we have dy dx, which we can go ahead and solve for. So, well, let's see. On the left side here, we have every term that has dy dx, so the 5y to the 4th has dy dx, and the 3x squared y squared has dy dx, but the 2y cubed x does not. Let's go ahead and just subtract this term to the other side of the equation, and it's going to be gone from this side. So, and then move over the x to the fourth dy dx. So we're going to have a plus x to the fourth dy dx on the left. We still have the 5y to the fourth dy dx, and then we have plus 3x squared y squared dy dx, and then we can subtract over the x to the fourth. So we have minus x to the fourth dy dx, and that's going to be equal to, well, it's going to be, we have a negative now, 2y cubed, but we still have the 4x cubed y over there, so we have equals 4x cubed y, and then minus 2y cubed, 2y cubed x. Okay, so now we can go ahead and factor out a dy dx from the left side. So we can factor out that dy dx, and then we factor it. So we say dy dx times what gets us back to the first term? Well, dy dx times 5y to the fourth is the first term, and then we need a plus 3x squared y squared for the second term, and then we have a minus x to the fourth, and that's going to be still equal to whatever's on the right. It's going to be equal to 4x cubed y minus 2y cubed x, and now we just divide through by this 5y to the fourth plus 3x squared y squared minus x to the fourth. That's going to then cancel, become 1, and therefore we get that dy dx is going to be equal to whatever's on the right, which was the 4x cubed y, 4x cubed y, and then we have what? We have minus 2y cubed x, so minus either 2y cubed x, or we wanted to write it as minus 2xy cubed, same exact thing. And that's going to be over that, what we just divided by, it's going to be over 5y to the fourth plus 3x squared y squared, so plus 3x squared y squared, and then we have minus x to the fourth, and there it is, dy dx is equal to all this junk, so therefore that is dy dx. Calculator, take care.